So in this experiment, we're going to measure density. What we have is a balance, a graduated cylinder, and our liquid that we're going to determine the density of. With the balance, it's got 3 decimal places, and that measures to the milligram. The graduated cylinder is a 50 milliliter graduated cylinder. With the graduations 1 milliliter apart, we will estimate to 0.1 milliliters. When reading a graduated cylinder, it's very important to make sure that your eyes are level with the graduation that you are reading. For example, the 40 milliliter mark, the line that circles the graduated cylinder is exactly eclipsed. Unlike the 20 milliliter mark, you can see that the line is not eclipsed. So I'm going to go ahead and tare the balance so it starts at 0. There we've got the tared balance with a 0 mass. I'm going to weigh the graduated cylinder. We're going to record this mass 64.804 grams. So now I'm going to go ahead and add the liquid to the graduated cylinder. So I'm going to read the meniscus at the bottom of the meniscus, and I'm going to interpolate. It looks a little more than 11, so the reading is 11.2. Now we're going to go ahead and weigh the cylinder with our 11.2 milliliters of liquid in it. And our mass is 73.240 grams. So now we're going to go ahead and remove the graduated cylinder from the balance and add approximately 10 more milliliters. I'm going to reread the meniscus, and I read 20.9. Now I'm going to go ahead and weigh my 20.9 milliliters, and the mass is 81.057 grams. Now I'm going to go ahead and add the third aliquot of the liquid. And so reading the meniscus of this one, I see about a little more than 30. It looks like about 30.3. Now that we've got approximately 30 milliliters, we're going to take the mass. And the mass is 88.397 grams. So we're done measuring the density of our liquid. We've taken 3 aliquots, recorded the volume and the mass for each aliquot. In this experiment, we're going to determine the density of a solid. We're going to start by determining the mass of the empty graduated cylinder. We'll add 20 milliliters of water, determine the mass and the volume of the 20 milliliters of water. After we've determined the mass and the volume of the 20 milliliters of water within the graduated cylinder, we will add approximately 15 grams of the metal solid. We'll then determine the mass and the volume of the solid and the liquid in the graduated cylinder. In your experiment, you are going to measure the density of an iron powder. In this demonstration, we're going to measure the density of these BBs. So to begin the experiment, we're going to measure the mass of the empty graduated cylinder. We're showing 65.138 grams. I'm now going to add 20 milliliters of water to the graduated cylinder. I'm going to weigh the mass is 85.298 grams. So now we're going to measure the volume of the water in the graduated cylinder. Looking at the meniscus, it looks like 21.2 milliliters. To determine the density of our solid, we're going to take the BBs and we're going to add them to our graduated cylinder with approximately 20 milliliters of water. We have that. Now we're going to determine the mass of the BBs plus the water, and we show 101.759 grams. Now we're going to record the final volume with our BBs and the water to be 23.2 milliliters. Now we've completed the experiment, the determination of the density of a solid by determining the volume and mass of a graduated cylinder before and after the addition of a solid.